In this lesson, we are going to discuss indefinite integral. Before we do the discussion, let's take a step back to definite integral. So in definite integral, I gave you a function f of x, and then I am interested in the area under the curve of f of x where x goes from a to b. So since if you take a look at the area, that is not a rectangle or a triangle where you can just use the formula length times width or the base times height divided by 2, so on and so forth to find the area. So to find the area of such shape, you have to use definite integral. So the area under the curve is equals to the definite integral of f of x dx, where x goes from a to b. So the result is equals to the area under the curve. How do we find the result? We have to integrate the function first and then plug in the lower limit and the upper limit using the fundamental theorem of calculus to evaluate the integral. But what about indefinite integral? So if you look to your right, indefinite integral, the difference between indefinite and definite is indefinite does not have the lower limit a and the upper limit b. You just take the integral of f of x dx. The result is equals to capital F of x plus c. So when we discuss in the previous lesson for the definite integral, we didn't discuss the plus c, right? Because the definite integral, the result is equals to a number, and that number stands for the area. But for indefinite integral, you have to add a constant to it, and I will explain why we need to add a constant in a minute. So let's take a look at the ingredients in the indefinite integral. So the capital F is the antiderivative of f. So when you do the integration, we say this, we are trying to integrate the function f. And then the c is a constant value like 1, 1.5, 2, 6, 10, negative 8, negative 7, so on and so forth. It's just a constant value. There is no x in it. It's just a constant value. And then f, we call it the integrand, and then the dx is the variable of integration. The dx tells me that the independent variable is x. So let's do a very simple example right here. I am trying to do the indefinite integral of x to the third power dx. So how do we do that? First, we take the antiderivative of the integrand. So we are not going to bring down the 3 and then take 3 minus 1. That is derivative. We are going to do it backward. So the way we do this is, so let me follow the colors. So this is x. We don't bring down the 3. We take the 3, we add 1 to it. And then in front of the variable, we have 1 divided by the power that we just wrote. And then we have to add a constant to it. I will explain why in a minute. And in fact, the plus c is not optional. You have to do this for every indefinite integral. Again, c is not optional. And then you have 1 over 4 x to the fourth plus c, right? The c is just a constant. So now your f of x is equals to 1 over 4 x to the fourth. How do I know this is right? Simple. All you have to do is you take the derivative of capital F, you will go back to the integrand x to the third, right? You bring down the power fourth and then take 4 minus 1. The 4 and the 1/4 got cancelled. 4 minus 1 is equals to 3. So you get the integrand, the integrand back. But why do we need to plus c? So the plus c is just a constant. But why do we need a plus c in there? So there is a plus c. You add some constant to it, right? What is the derivative of a constant? The derivative of constant, what is the derivative? So for example, answer my question. What is the derivative of 10? Which is 0. Why? Because y equals to 10 is a horizontal line, right? What is the graph of y equals to 10? It's a constant line, right? It's not a constant line, it's a horizontal line, so there is no slope. The line is a constant, is a flat line. The line is not going up or going down, so the slope is equals to 0. And in fact, derivative is all about slope, right? So the slope of a horizontal line is 0. So that's why the derivative of 10 is equals to 0. So why do we need to plus c? So when you find an answer like this, the 1 over 4 x to the 4 plus c, we call this an antiderivative, right? An antiderivative. Another name for this is called the general solution, because we don't know what the constant is. But how do we find the constant? to find the constant, I have to give you another condition. So f of 0 is equals to 1. So that means when x is equals to 0, y is equals to 1. So you do this. So f of 0. So when x is equals to 0, so f of 0, you plug in the 0 to the function. So 0 to the fourth plus c is equals to 1. And then you have to solve for c. So it's easy. So 0 plus c is equals to 1. So that means c is equals to 1. And then now you write the answer. So that is equals to 1 over 4x to the fourth plus 1. So this is called the antiderivative, right? And then we call this particular solution. So again, back in definite integral, you have to use the fundamental theorem of calculus to evaluate the integral. In indefinite integral, you have to finish the problem with plus c unless the problem gives you an initial condition and then asks you to evaluate the c. All right, so let's go over some formulas because I want you to review your derivative and antiderivative skills. So let's switch to another color. So let's take a look at the easiest rule first. So what about the derivative of x raised to the nth power? This is the simple power rule, right? So you bring the n down and then x raised to n minus 1, right? So what about the integral of x to the n dx? So this one you have is antiderivative. So you have to take the n plus 1, 1 divided by n plus 1 plus c. So that's the first one. And then the next one is the derivative of, this is a good one, ln absolute value of x. So the derivative of ln is 1 divided by x. When you do the integral of 1 over x dx, so this one is not the simple power rule anymore. So that is equals to ln absolute value of x plus c. When I write an exam, I always put this kind of put the integral of 1 over x on my exam, always. And then the next one, so the derivative of e to the x is e to the x. It doesn't matter how many times you take the derivative. So therefore, the integral of e to the x dx is just equals to e to the x plus c. Again, when you do indefinite integral, you have to plus c every single time. The plus c is not optional. Next, we have, let's try a trigonometric function, right? So the derivative of sine is equals to cosine, right? So the integral of cosine, so we undo the derivative, that is equals to sine, right? Sine of x plus c. And then the next one, how about the derivative of cosine? So that is equals to sine of x. Did I miss something? Yes, I missed a negative. How about the integral of sine? I didn't include the negative. So the integral of sine is negative cosine x plus c. People miss the cosine all the time. And here is another one that you will be using in statistics, in integral calculus all the time. So that is the derivative of tangent x, that is equals to secant square x. So therefore, the integral of secant square x dx is equals to tangent x plus c. And then let's do the other three trig functions. So switch to another color. So the derivative of cosecant x, that is equals to, still remember that, negative cosecant x cotangent x. So therefore, the integral of cosecant x cotangent x is equals to negative cosecant x plus c, because I didn't include the negative in the integrand. Okay, two more. The derivative of secant, that is equals to secant x tangent x. And then the integral of secant x tangent x is equals to secant x plus c. And then I want to give you two more. So first, let's do the cotangent. So the derivative of cotangent is negative cosecant square x. And then the integral of cosecant square x is equals to negative cotangent x plus c. Oh, do you need to memorize all of this? Yes and no. The answer is yes if you are not allowed to use any note card or cheat sheet on the exam, when I was in my calculus class, that is not allowed. I have to memorize all of them. But if you are able to use note cards and or cheat sheets, and you can just put it in there. I don't recommend you to go that way, because if you memorize that, you will feel more confident and you will be able to react much faster. That is based on my experience. Oh, one more thing, you will be using this a lot. Not a lot, but it gives you some benefit if you can take a couple minutes to memorize this one. X squared plus a squared dx. This is also my favorite integration formula. So that is equals to inverse tangent x divided by a plus c. I believe that there is another piece over there. I believe that there is another x1 divided by a in there. Here. This piece. Alright, so that is the end of this video. In the next video, I will show you more example about how to do indefinite integral. If you think my instruction is helpful, let me know in the comment below. Like the video, subscribe to my channel. Thank you for your support. I will see you all in the next lesson. Signing out for now.